Salam doctor, good morning, good afternoon, good evening. I'm Sia Hong and today I'm going to demo about my experiment tool, which having a title of Design Automation System using Automation Studio software. So first of all, let us get into our experiment. So in this experiment, we will more focus about PLC and the ladder diagram. So for the first task, we're having this circuit right here, and we have to construct this ladder. So yep, where is it? Task B, Task C, Task A. So this is the simulation file. Let us simulate it. So when we press the start button, the motor will rotate anti-clockwise. So if we stop, the motor will stop rotating. If we press reverse, the motor will rotate clockwise. And if we press LS1, it will stop the motor. If we press LS2, the motor will rotate clockwise. So this is a simulation on the task, the first task. And we can see that here is a latching circuit, which means that if the start button is being pressed, okay, let us stop first. Okay, the output right here will energize this switch, and then the switch will latch the whole circuit. So even though the first input is being stopped, the circuit is still flowing. So this is something known as a latching circuit. So for the task, second task, okay, we have a situation. Figure 1 shows a tank for chemical cleaning of metallic object. The basket with metallic object must be immersed inside the tank once according to the following plan. By instantaneously pressing the button start, the basket must be immersed once into the tank. After the immersion, the basket returns to the up positions and remain there until the next pressing of the button start. So what's happening in here is that the user must to press the start button so that the basket will go down and immerse inside this liquid. And once the things right here contact with the limit switch 2, then the whole conveyor will pull up the basket and reach limiting switch 1. And after that, if users want to have a next cycle, then you will just need to press the start button again. So my circuit for these questions is basically something like this. So as we can see that there is only 4 input, which is start, stop, LS1, LS2, and only 2 output for controlling the directions of the motor rotate. So why we have 2 outputs? Because going up and down is actually depends on the motor. So if the motors rotate anti-clockwise, the basket will go down. If the motors rotate clockwise, the basket will go up. So the simulation, we have to start it. Okay, start. Okay, start. When we press the start button, the motor will start rotating anti-clockwise, which means if the motor go in this direction, it will push the basket going down. Okay, once the basket going down and contact with the limiting switch 2, then the limiting switch 2 will be triggered. So, and now the motor will rotate clockwise. Okay, when the motor rotate clockwise, it will pull up the conveyor belt. Okay, when the conveyor belt is being pulled up, then this small tiny box right here will contact with the limiting switch 1, and thus stopping the rotations of motor. And the user just have to press start button again to activate the next cycle. So we can stop anytime. So this is basically something like emergency stop button. So for example, like start and stop. Okay, start, go down, and I want to stop it. Okay, also can. So I have to press LS2 again, and then LS1, and then stop. Okay. So for the third question, it is a bit complex because a long bunch of words right here. So I actually made some simple version of the flow. Where is it? Okay, lab 2 industrial automation. So we have 4 input, okay, and then we have 5 output. So what happenings inside these questions is that whenever we start the system, okay, so like imagine we just turning on the switch, and then the whole system will be in standby indicator lamp on. Means that the standby indicator lamp will be turned on. Okay, so if we press the start button, the conveyor belt will on, and then the run indicator lamp will be on, the standby indicator lamp will be off. So if we stop, or if we press the stop button, the conveyor belt will stop, and the run indicator lamp will off, and the standby indicator lamp will on. So once the conveyor belt bring the loads into a correct positions, the PC sensors will triggers. And whenever the PC sensor triggers, it will stop the conveyor belt and then will open the knife gate. Okay. After that, the level sensor at the level switch right here will detect either the barrels is already fully loaded or not. So if it was full already, then it will triggers, and then the knife gate will off and the full indicator will on. Then users will have to press the start button manually to turn on the conveyor and deliver the conveyor out of the systems. So okay, stop simulations and we're going to get the last question. So this is basically my circuit. And we can see that I have used a lot of latching circuit right here. 1, 2, 3, 4, 4 latching circuit, 4 input and 5 output. And this is the motor. But we don't really need the motor, we just have to observe this part. Okay. So whenever we turn on the system, okay, the system will be in standby mode. And if we press start button, the conveyor belt will be run. M1 is means that the motor will start running. Okay. After the motor start running, there will be a lamp indicates that our system is in running mode. So the lamp will be turned on. Okay. After that, the barrel will be bring into the correct positions, and the photocell sensor will sense it and trigger the PC switch. Okay. So whenever the PC switch being triggered, the valve will be open. The valve right here means the knife gate right here, the knife gate valve. Okay, the material will fall into the barrel, and whenever the barrel is full, okay, the level switch will be triggered. Why the level switch will be triggered? Because level switch is a kind of sensor that detect either the barrel is full or not. So if the barrels is full, the level switch triggers. Okay, still in run mode, and also we have another indicating light, which means that the barrel is already full. Okay, then the user will have to press the start button manually, then to run the motor again and deliver the barrel out of this system, and also bring the new barrel inside the system. So, okay, let's say we have a PC. Let's say, okay, the barrel is already in the correct positions and it's already full. Okay, but now I want to stop my system. Okay, I just press stop. Okay, now the sensor run mode is already off, and the full barrel is still on because the barrel is still there, right? So the sensor will keep triggering, and then it will be in a standby mode because the system is already stopped. So if we just press start, okay, and then we deliver the barrel out, and that will be in run mode again, and the motor will be triggered. So this is basically how the system runs, and this is the most simple versions of ladder diagram that I can design. Okay, so yeah, this is the answer. Thanks for your patience on listening my presentation. Thank you. Bye bye.